Okay, I have the question 9 to the x minus 2 times 3 to the x equals 15. And we want to figure out what that means. Let's take a look at something like 3 to the 5th. That's 3 times 3 times 3 times 3 times 3. Yes. How about 3 to the 5th squared? That would be 3 times 3 times 3 times 3 times 3 multiplied by 3 times 3 times 3 times 3 times 3. So that's 3 to the 5th times 3 to the 5th, which is the same as 3 times 3, 3 times 3, 3 times 3, 3 times 3, 3 times 3. See, this first one times this first one, the second one times this second one, this third one times this third one, this fourth one times this fourth one, this fifth one times this fifth one. So 3 to the 5th squared is the same as 3 squared to the 5th. The reason I'm saying that is because I have 9 to the x here. Okay. And again, when you raise a power to a power, you multiply the exponents. 5 times 2 is 10. 2 times 5 is 10. Another way to see that. 9 to the x, 9 is 3 squared to the x, which would be the same as 3 to the x to the second power again. Multiply the exponents. 2 times x, x times 2 would be the same. So I can rewrite this question as 9 to the x becomes 3 to the x squared minus 2 times 3 to the x equals 15. And this looks like a quadratic equation. I'm going to introduce a new variable. I'm going to say let u equal 3 to the x. Now we're not solving for u, we're going to solve for x, but we will solve for u first. So 3 to the x squared becomes u squared minus 2 times 3 to the x will be minus 2 times u equals 15. Let's subtract 15 from both sides, and what do we get? We get u squared minus 2u minus 15 is 0, and that requires me to do what? That requires me to factor to solve. So let me do that. What are we going to have here? Draw our factor box. U squared here, minus 15 here, minus 2u there. So u times u minus 5 here, plus 3 there, minus 5u, plus 3u is minus 2u. So we get u minus 5u plus 3. U minus 5 times u plus 3. So that's what we get here. We get u minus 5 times u plus 3 is 0. Remember, we're solving for x, not for u. So u minus 5 is 0. Or u plus 3 is 0. So here we get u is 5, or u is negative 3. But what is u? U is 3 to the x. So 3 to the x equals 5, or 3 to the x equals negative 3. But is 3 to the x ever equal to negative 3? Is 3 to the x ever equal to 5? Let's take a look at the graphing calculator. Let's get rid of this, call it 3 to the x. And I will go with zoom standard maybe this time. And you're looking at the graph of 3 to the x. Now 3 to the x certainly could equal 5. Where does 3 to the x equal 5? Three to the x equals 5 where these two things intersect. But does 3 to the x ever equal negative 3? Negative 3 is down here. 3 to the x never equals negative 3. So looking at this, I can throw this piece out. This is not going to have a solution, but I am at the point where I have 3 to the x equals 5. So if I have 3 to the x equals 5, how do I solve that? I'm going to take the natural log of both sides. You could take log base 3 of both sides. I like to always use the natural log. Log 3 to the x equals natural log 5. Pull the exponent down in front. So we get x times natural log 3 equals natural log 5. Divide both sides by natural log 3. And we get x is natural log 5 over natural log 3, which is approximately how much? So again, we'll go to the graphing calculator to see what that is. Natural log 5 over natural log 3. Natural log 5 divided by natural log 3. And we get approximately 1.465. Now, I want to check that. So let's go back to our original question here. So it's about 1.465. Our original question at the top of the page was 9 to the x minus 2 times 3 to the x equals 15. And I checked it on the graphing calculator. I think it's somewhere between 1 and 2. What I'm going to do is I'm going to subtract 15 from both sides. I'm going to say 9 to the x minus 2 times 3 to the x minus 15 equals 0. And then I will use my 0 finder on the calculator to see if I indeed get that number that I expect, 1.465. So let's jump back to the calculator and get rid of everything that's there from before. And I want to see, when is this new function equal to 0? So 9 to the x minus 2 times 3 to the x minus 15. When does this equal 0? And again, I think it's between 1 and 2, so I'm going to start with zoom decimal. But I may have to adjust. If things are vertical, I want a whole lot more y. But let's see. What do we see? It's pretty close to vertical. I could certainly add a little bit more y. Maybe I'll multiply it by 4. Seems like a good number. Just so we see a little bit more play in the graph. And get a better idea of how it's behaving. There we go. So I want to find the intersection point, so the 0 point. Where does this function cross 0? Second calc, 0 finder, a little bit to the left of the crisscross point, which is about there. That's good. A little bit to the right of the crisscross point. That's there. That's good. Guess. That's there. That's good. What do we get? 1.4649, 1.465. What did I want it to be? About 1.465. So that looks good.